Equations. So before we start solving these equations, we need just a really quick review of order of operations. You might remember order of operations using the first letter of each one of these words. So PEMDAS, PEMDAS. Please excuse my dear Aunt Sally. However you remember it, the steps are the same. Notice that there are not 6 steps, but really only 4. So first we do anything inside the parentheses. Then we simplify any exponents that we may have in the expression. The third step is either multiplication or division, whichever comes first, left to right, until all of that is done. And then the fourth step is to either add or subtract, whatever comes first, left to right. So we're going to use that order of operations. And I'm also going to use a few symbols to represent some objects. So these are the symbols that I'm going to use to represent the objects that I'm going to show you today. The pentagon is going to be used to represent a toy or an object that we're going to give to someone. The square is going to represent a box. Then this shape over here is going to represent wrapping paper. And then the cube is going to represent a present. So when you wrap a present, you start with the toy. You put that toy in a box. Then you put wrapping paper around the box. And then you have your completed gift. And you're ready to hand it off to the deserving recipient. So we do this in a very certain order. We can't give the gift before we put the toy in the box. We can't wrap it before we put in the, right? So there's a very certain order that this has to be done, just like order of operations. When you unwrap the gift, there's also a certain order that we have to follow, right? We first have to take off the paper. So before we're putting it on, now we're taking it off. We have to then look at the box and open the box, right? And then we're taking the gift out of the box. And then we have the toy or the object that we wrapped. So when we unwrap the gift, we're doing the same things we did to wrap it, but we're undoing at each step and we're doing the order backwards. So that's the same thing that I want you to think of when we're solving equations. So first, let's wrap the x. If I follow order of operations here, the very first thing that I would do to this x, if I knew the number, the very first thing I would do is multiply by 7 because that's what comes first in order of operations. The next thing I would do would be to add on the 24, right? Because addition comes after multiplication. And then I would get my answer of 28. So now when I'm unwrapping it, I'm going to start with the 28. I have to undo, right? I have to take off the wrapping paper. So to take off the wrapping paper, I'm going to do the inverse, which would be to subtract the 24. Then I have to take it out of the box. So that would be divide by 7, because I'm undoing the multiply by 7. And then I'd have my gift, right? So when we do something and then we undo it, that's called using inverse operations. Okay, let's look at one more, and then we'll do it algebraically. So this one has an extra step, so I had to add an extra box. So for this one, again, I always start with the variable, right? Always look at the variable, because that's the part that we want to just have alone, right? We want to get back to what is that variable equal to. The first thing that would happen to that variable is I would multiply it by 6, right? Because I go inside the parentheses first, and inside those parentheses, I would have to multiply before I subtract. So I would multiply by 6, then I would subtract 11, right? Then after I figure out what's inside the parentheses, then I would multiply by 1/3, and that would get me to 2. So when I am unwrapping this x, I have to undo at every step. So start with the 2. I undo the multiplying by a third, right? That's kind of like taking off the wrapping paper. Then I would have to undo the subtracting 11, so I would add 11. Then I would have to undo the multiplying by 6, so I would divide 6. And then I would get back to my value of x. All right, now we're going to do the same 2 problems, but without the images. We're going to do it completely algebraically. So just as a reminder, I'm going to write our order of operation steps over here. So I would start with the x, right? Then the first thing I would do is multiply by 7. The next thing I would do is add 24, and then that would get me to my answer, right? So remember, we're going backwards in our order, but we're also using inverse operations to undo each step. So if I go back, the first thing I have to undo is adding 24. The inverse of addition is subtraction, so I'm going to subtract 24. Now, you'll notice that I'm doing it from both sides. You can think of an equation like a balance scale. As long as you do the same thing to both sides, the scale will stay balanced. But if you do one thing to the left side and not to the other, now you don't have equal sides anymore, right? Because for them to be equal, remember, we have to keep that scale balanced. So in order for the left side and the right side to remain equal, we have to do the same thing to both sides. So I can see that subtracting 24 will undo my adding 24, right? Because that equals 0. So I bring down my 7x, and then 28 minus 24 is 4. Okay, now I have to go back another step. So now to undo my multiply by 7, I would have to divide by 7. So I divide by 7 on both sides. 7 divided by 7 is 1. And I get x equals 4/7. Now, sometimes you may be asked to write your final answer as a decimal. That's fine. We know how to convert that to a decimal. But for these problems, I'm just going to leave it in simplest fraction form. All right. Here's the other one that we looked at. And just as a reminder, I'll write what that order was that we used. So first we started with the x, right? Then we multiplied it by 6. Then we subtracted 11 because we have to do the parentheses first. Then we multiplied by a third, and that gets us to 2. So now when we're solving the equation, we have to go backwards, right? So the first thing I have to undo is the multiply by a third. Now, I need you to think about what we did just like a few lessons ago, a few videos ago. We know that in order to, well, first of all, to undo the multiplication, we have to use division. And how do we divide by a fraction? Are you thinking about it? When we divide by a fraction, we do keep, change, flip. So to divide by a third, that's the same thing as multiplying by 3. That's how we do it, right? Dividing by a fraction, we keep, change, flip. So I'm going to do that on both sides of my equation first. Actually, I'm going to rewrite it down here so that I have a little more room. And then I'm going to multiply. I'm going to do this on both sides. So I'm going to multiply by 3 over 1. And here I'm just going to multiply by 3. I could write 3 over 1, but it's not really necessary, right? I don't really need it. So 3 times 1 and 1 times 3, that gives me 3 over 3, which is 1, right? Any number over itself. So that's gone, right? I undid it. That was the whole point. So now I've got 6x minus 11 equals 2 times 3 is 6. All right, so now I have to go back another step. I have to undo subtracting 11. So to undo that, I'm going to add 11. And that gives me 6x equals 7. Okay, and then I go back another step. I have to undo multiplying by 6. So I divide by 6. 6 divided by 6 is 1, so I get x equals 7 over 6. All right, and again, you can convert that to mixed number or decimal. All right, let's try one that we didn't look at with the images, right? Let's do this one completely algebraically. So first I'm going to look at my order of operations. And my order of operations, if I start with that x, right, would tell me to first multiply it by -4. Then I would add 14, and that would get me to 7. So now that I am solving the equation, I'm undoing and I'm working my way backwards. The first thing I have to do is undo the adding 14. So I'm going to subtract 14. I'll bring down my -4x. 7 minus 14 is the same thing as if you were going to add 7 and -14, right? 7 minus 14 is the same thing as 7 plus a -14. So that equals -7. All right, so now I have to go back another step and undo. So undoing multiplying means I have to use division. So I'm going to divide by -4. Notice that I'm always using the inverse operation, right? That's the operation that will undo. Division undoes multiplication. Addition undoes subtraction, right? If I add something and then I take it away, it undoes the addition, right? So -4 divided by -4, that equals 1, and I just get x. And then a negative divided by a negative equals a positive. And I'm going to leave it like that. Again, could be a mixed number, could be a decimal, but I'm going to leave it in simplest fraction form. Let's try one more. All right, so I'm going to start off with writing what my order of operations would be. So if I start with the x, the first thing I would do would be in the parentheses, right? So I would subtract 10. Then I would multiply by -1/5. And that would get me to my answer. So now we just have to do all of that backwards and undo each step. So the first thing that I'm going to undo is multiplying by -1/5. How do I undo multiplication? With division. So I need to divide by -1/5. Dividing by -1/5, how do I do that again? Think back. Dividing by a fraction means I do keep, change, flip, right? So I'm going to divide by -1/5, and the way that I'm going to do that is by doing this. So on this side, I'm going to once again rewrite my problem a little bit lower so that I have more room. Okay, so I'm going to multiply by the reciprocal, right? Because that's how we divide fractions. I don't really need to write 5/1 on this side, so I'm just going to leave it as -5. So on the left, I multiply top times top and bottom times bottom, and I get -5 over -5, which is just 1. So now I have x minus 10 equals a negative times a negative equals a positive 35. Now I go back another step, and I'm undoing the subtracting of 10, so I would have to add 10. And I get x equals 45. Now, you do have another option for this problem. Anytime you have a number outside of the parentheses, you could always use the distributive property first. So I want to show you what that would look like. If I do that, let's start off with our original problem again. I would distribute this fraction in first to simplify on the left side. So if I do that, I get -1/5 x plus, right, a negative times a negative, plus 2. And if you're not sure about that fraction multiplication, just check me out over here off to the side. You would have -1/5 times -10 over 1, right? Negative times a negative is positive, so you would get 10 over 5, right, which is 2. Okay, so let's keep going. So from this step, this is where I would start to write out my order of operations, right? So if I start with this x, the first thing that happens is it gets multiplied by -1/5, and then we add 2 to it, right? That's the order of operations that's happening here with the x. So just like before, we've got to undo. So the first thing I would undo would be the adding 2 part, so I would subtract 2. And that's -1/5 x equals -9, right? -7 minus 2 is the same thing as -7 plus -2, right? You can always look at it that way. Now I need to undo multiplying by -1/5. So I have to divide by -1/5. But we already looked at what that means. Dividing, let me write it over here. Dividing by a fraction is multiplying by the reciprocal, right? So we're going to use that right here. I'm going to multiply by, oh, I forgot my negative here. I'm going to multiply by the reciprocal. And over here, I don't really need it to be a fraction, so I'm just going to write it as -5. So just like we saw before, this equals 1, and I get negative times a negative is a positive. I get the same answer. I feel like this method over here is a little bit less work because there's just a little bit less fraction work involved, right? You multiply by that reciprocal of the fraction right from the beginning, and then you don't have any more fractions in the rest of your problem. Whereas the second method, I distributed in the fraction, so not only did I have to do fraction multiplication, but then when I undid it, I had to also do fraction division. So either method, you'll get the same answer. Use the one that works best for you.